Talk about exponential graphs. And luckily your exponential graphs can't have transformations. Shh. Quiet, please. So, our exponential graphs are just plain basic graphs for the most part. Our exponential graph will always be in the form y equals a b to the x, just like our exponential regressions did yesterday, right? They were in the form a b to the x, yes? Now, let's look at this one. If I give you this, y equals 3 to the x. And everyone type that one into the calculator. Y equals 3 to the x. When we did word problems, and we had a 3 here, what was happening? When we had a 3 in our R, what was happening? The graph was, starts with a T, rhymes with rippling. Tripling. It was tripling. And if this was a 2, it was doubling. And if it was a half, it was halving, right? If it was above 1, it was increasing. If it was between 0 and 1, it was decreasing. We agree? So I know that if my b is greater than 1, my graph is doing what? Increasing or decreasing? Increasing. It's increasing. And I know from my word problems again, if that value is between 0 and 1, so for example 0.80, that means my b is between 0 and 1. What would my graph be doing? Decreasing. Now, I want to know, that's decreasing, but what's it decreasing by? How much? 20%. It's not decreasing by 80%, it's decreasing by 20% because it's how far away it is from 1, right? Okay, so if I give you a graph like this, this is what you have in front of you. Now, is this the most accurate graph? I didn't even draw a dot. I just went, whoo. So is that a perfectly accurate graph that you get full marks for on a test? You're all going, because you're joking, because you know. No, you wouldn't. If I want an appropriate graph, go to your calculator. I want you to sketch it, please. So we're going to go to our calculator, and we're going to type in y equals 3 to the x. Did not need to do that. There. Okay, so we're going to type in, if we haven't already, 3 to the power of x. And we press graph. And I have a wonky graph because I made a really weird window before. So I go zoom 6. Okay? I expect when it says the word sketch, it doesn't mean it wants it to be sketchy. Like you're like, sketch just means like, you guys have a different definition of sketch than what sketch actually means in math. Sketch in math means to draw the graph accurately. That's what sketch means. It doesn't mean to make it sketchy. Like I could just and call it a day. Okay? So if I'm going to go actually graph this graph, so glad it made this small. 1 second. I'm going to go like this. I'm going to go like this. I'm going to go like this. Okay. So I need to sketch an accurate graph. Shh. So how do I do that? I can go to my table, or I can go second trace value and put in any x value. We agree? So if I go second trace value -4, it gives me really, really small. And I'm so glad it's doing this little blue box. This is going to be amazing.
Second graph.
I can't ever get it to go away. Stop. All right. So at -4, we're really close to the x-axis. But are we touching the x-axis? No, we're 0.0123. We're really close to it. Yes? Then I want to do -3. Second trace value, -3. Still really close, but a little higher. But basically in the same spot. Then second trace value, -2. Oh, now I'm at 0.1, so I'm a little higher. And then second trace value, -1. Now I'm at 0.3. I'm a little higher. Then second trace value, 0. I'm at 1. No. I don't even... Just back up these things. 1. Second trace value 1 is 3. Something miraculous just happened, and I don't know how, but cool. And then second trace value 2, and we get 9. I don't even. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we're at 2 and 9. And then it runs along here. It's getting closer and closer to the x-axis, but it's not touching it. And then this is going up here. So I have an arrow up here. This is getting really close to the x-axis, and there's an arrow going this way. So it's going to get close and close and close to the x-axis, but it's not going to touch it. Is everyone paying attention? So what is actually on that x-axis? If you were in grade... No. Wow. What is going on? It does it only in your class. Like royally Brooks. Okay. If you were in grade 11 last year, you would have talked about these. Okay, it's just whatever. It's going to draw. We'll go with it. You have a horizontal asymptote. That's what it's called on the x-axis, which is a dashed line. Because it doesn't actually exist. It's a dashed line where the graph can't go through. This is called a horizontal, because it's horizontal, asymptote. So it's a line that doesn't exist. Now it's on the x-axis. Does anyone know the equation of the x-axis? Which one? X or y? Y. Because what's 0 on the x-axis? All the y values are 0, right? Every single place you have a different x value, but all the y's are 0 on the x-axis. So the x-axis is actually the equation y equals 0. And they'll ask you, what is the horizontal asymptote? Or what asymptote does this graph have? You have to say it's a horizontal asymptote at y equals 0. So I have to draw that on there too. What would my domain be of this graph? XCR, because it's going out for life like this, correct? X and L in the real is going forever this way, and it's going forever this way. So it'd be X such that X and L in the real. The set of X values such that X and L are the reals. And then the range. Y such that Y is what? Greater than what?
0.
0. Is it equal to 0? No, the graph gets really, 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 really close to 0, but it's not equal to 0. That's where the actual asymptote is. So, it's going to be greater than 0. Y is now in the real. What are my x-intercepts? Trick question. There aren't any. Why are there no x-intercepts? Yes. The asymptote is on the x-axis, which is where the graph can't be. So there are no x-intercepts. And what is my y-intercept of this graph? 0 and 1. I drew it. So that's the graph 3 to the x. We agree? E was greater than 1, so it was increasing. I want you guys to sketch this now. Y equals 0.8 to the x. I want you to draw the graph accurately, so sketch it. Now, guys, the catch is this. You always have to say what your scale is, correct? So we're going to say x scale of 1. That just means every tick is worth 1. And y scale of 1. So I want you to sketch the graph. I want the domain, the range, the x-intercept, the y-intercept, and the asymptote. Right up. So we are connecting all of the dots, and then it's running closer and closer to the x-axis, but it is not touching it. And then you should have, every single one of you, look, you should have a horizontal asymptote along the x-axis. So make sure you have a dashed line on the x-axis, or you don't actually have a correct graph. Just put it on the desk in front of you. I don't care. The domain is x such that x are now in the reals. The range is y such that y is
greater than 0.
Greater than 0. The x-intercepts are none. The y-intercept is 0, 1. And the asymptote is a horizontal asymptote at y equals 0. Now I know I have to repeat this 80,000 times because you guys don't listen. If you do not have it exactly how I have it, yours is wrong. So if you write y-intercept 1 and not a coordinate, yours is wrong. If you don't write horizontal asymptote y equals 0, yours is wrong. If you write 0 with no y equals, yours is wrong. You have to have it exactly like mine. So some of you are like, it's close. It's close gets you no marks. Okay? So you have to have it exactly how I do. If you're like, I don't want to, well then you're just conceding to not getting full marks or any marks possibly on your diploma. Those are your options. You can make them decision yourself. I wouldn't choose that way. All right. So if I give you this 1, 2, 3, and I give you y equals 2, 1.46 to the x, and I give you y equals 3, 0.70 to the x, and I give you y equals 1/2, 3 to the x. I don't want them sketched. We've already shown we can sketch a graph. I want all the information about it though. I want what the asymptote is it horizontal, vertical, and what is the equation? I want if it's increasing or decreasing. I want the domain, the range, and the x-intercept and y-intercept. All right, so for every single one of these graphs, does the asymptote change? No. It is a horizontal asymptote. Guys, I literally just had this discussion. No, it's both of you. Horizontal asymptote, y equals 0, the whole way across. Oh. Does the domain change on these graphs? No. They're always x such that x is an element of the reals. Because they go on for life. Even if they are increasing or they're decreasing, they still go out forever. What about the range? The asymptote doesn't change, the range doesn't as well. So it's y such that y is greater. Always type them into your calculator too, because there could be some that reflect down and be less. But when you type it in, you'll see that it's below. But it can't be equal to it, which you guys do on the test. You tell me it's greater than or equal to. It can't be equal to, because that's where the asymptote is, where the graph can't be. What about the x-intercepts? If my asymptote is on the y equals 0 x-axis, then there are no x-intercepts. None, the entire time. So you see how some of these things stay the same no matter what I give you if it's an exponential graph? Do the y-intercepts stay the same? No. We'll talk about those in a second. What about increasing, decreasing? Does it stay the same? No. This one is greater than 1. B is greater than 1, so it is increasing. And how much is it increasing by, guys? 46%. It's by how much more it is than 1. Okay? Is this one increasing or decreasing? Is this increasing or decreasing?
Decreasing.
Decreasing because it's between 0 and 1. By how much?
30%.
30%. And then what's this one doing? Increasing or decreasing?
Decreasing. Increasing.
B is greater than 1, so it is increasing. By how much percent?
300.
300. Because it's 3 times the original, and the original is 100. Okay? Now, how do I get y-intercepts? I plug 0 in for what? X. So if I have this one, y equals 2 bracket 1.46 to the x, and I'm plugging 0 in for x, this is going to become a 0. We agree? What's anything to the power of 0? Nope. Anything to the power of 0? Put something in your calculator to the power of 0.
Error.
No, it's not.
It's a 0.
No, it's not.
It's a 1.
It's a 1. Anything to the power of 0 is 1. So this becomes a 1. What's 2 times 1? 2. So my y-intercept is at 0, 2. You must write it as a coordinate. 0, 2. Now if I go to do my y-intercept of 3 and 0.7x, y equals 3 bracket 0.70x. Well, my x becomes a 0. Anything to the power of 0 is 1. So it's going to be 3. So my y-intercept is at 0, 3. It's going to pick that up, but whatever. That's on you. All right. Y equals 1/2. 3 to the x. X becomes a what? 0. This becomes a 1, and I get 1/2. So it's 0 1/2. All we have left to look at is log graphs. So an exponential graph and a log graph are inverses of each other, so they just flip-flop. So let's talk about just a basic log graph. Y equals, this is log graphs. Y equals log base 3 of x. Everyone type that in. It will look like the log graph is stopping. And if on a test you tell me it stops, or you pull me over and you're like, Mrs. Lepp, I know you said it's y is an element of the reals, but it's not. Yeah, it is. The calculator looks like your graph stops. It does not stop. So if I go second trace 1, second trace value 1, and I get 1 and 0, and then I do second trace value 0.75, because I have to get closer, I get negative 0.26, so it's here. And if I do second trace value 0.5, I get negative 0.63. Then I do second trace value 0.25, I get negative 1.26. And then I do second trace value 0.1, like I'm just trying to get closer to 0, I get negative 2.09. If I want to get even closer, I can go second trace value 0.05, and I get negative 2.72. So this graph is actually curving and riding along this entire y-axis. Even though your calculator looks like it stops. Do you see that, Mark? Yeah, you don't, but that's okay. The line actually carries along the y-axis and goes to the bottom. You won't see that. You literally can't. Your calculator cuts it off. But the graph doesn't stop there, okay? It just gets so close to the y-axis that it almost cuts itself off because it can't keep drawing it, but it actually does keep drawing. And then if I go second trace value 2, I get 0.63. Then I do second trace value 3, and it's 1. Second trace value 4, and I get 1.26. So this graph is going like this. We agree? So it's actually the complete opposite of an exponential. This is an increasing log. My asymptote is not a horizontal asymptote anymore. It is a vertical asymptote. And what's the equation of the y-axis? Which is where it's on.
0.
What is 0?
Or x equals 0.
X equals 0. So the y-axis is actually x equals 0, and the x-axis is actually y equals 0. They're complete opposites of each other, exponential and log graphs. So exponential graph had a domain of xer. We agree? A log graph has a range of yer. They're the opposite. So this one's going to go down to the ground for life and then up. So it has a range of yer, the complete opposite of exponential. And exponential had a domain of xer, so we have a range of yer. Exponential had a range of y is greater than 0. What does this have? A domain of x is greater than 0. Not equal to. Exponential had no x-intercepts. What does log have? No what?
Y.
No y-intercepts. And this one has an x-intercept at 1, 0. Now, if I actually do y equals log 1/3 x, it'll make it decrease. So if my b, remember, if the b is greater than 1 on an exponential, it increases. If b is greater than 1 on a log, it increases. If b is between 0 and 1 on exponential, it decreases. If b is between 0 and 1 on a log, it decreases. So if this was a third, it would decrease. Also, if it has a negative in front of the log, it decreases. So before you go to tell anything about the graph, draw the graph. And what if they give you variables? Well, they'll have to tell you what those variables stand for. So if they say b has to be greater than 1, then put a 2 in and look at it, right? Like there's no stopping you from doing that. Now, I do have some questions out of the textbook, not the workbook. The textbook's the hard-covered one. So go grab one. I'm going to write the questions on here.